Alrighty then. So, I will tell you, today and tomorrow are your wonderful opportunities for us to make some headway and tell Blue that they got to step up their game, because those boys were turned up yesterday when they came in here after the map test, which is why now you're going to just map test as the last thing in the day, because after sitting for 2 hours, Colin and Sebastian and like Ben and AJ and Cooper and Ivan, it was like, or sorry, no, you guys are here now. It was like Ivan and Cooper. I'm sorry, I saw you guys walking this morning, and I don't know why I thought you were here yesterday. They could not chill. They were just like, oh, it's like electricity. It's like, guys, you just took a test for 2 hours. Like, I get it, but come on. So first things first, Khan Academy was due. Yeah, not yesterday. That would have been 2 days ago for you guys. So if it's not done, please get it done. I'm going to be updating map more quickly than in the previous quarters because you're here, and if you have questions, you should come work with me. So I almost went and updated it yesterday. And actually, I forget if I did or didn't. Let me go check. Yeah, no, so I haven't yet. So you're still getting a tiny bit of grace that you're past due right now, but you can still get it done. So get it done. We're going to talk about your math notebook moving forward. If you never turned one in, I do still need to see it, and your grade is probably a missing in math. Your linear equations unit test, if it's in map as missing, guess what? You didn't submit it. It's tough for me to grade something that doesn't get submitted because I can't see it. So, if you have a missing, submit it. If you have a progressing, you got two options. One's easier than the other. The harder option, not advising that you take this, but some of you already have, is do the unit test again. Because you can, you're allowed. That's not what I'm saying you should do. I looked at all the results that I was able to look at so far, and I looked at the common mistakes. So in Schoology, there is, I think it's only 5 questions, a Progressing to Mastery linear equations inside our new quarter 3 folder. If you have a progressing, not a missing, a progressing, you may just go in and do that. That is an option for getting from progressing to mastery. Now, if you want to go do the 24 question whatever test again, you can. But you do not need to go back and answer all 20 whatever questions again. Because I know what the common mistakes were, and I know what we need to talk about to make sure that you're mastered. Yeah, right? Math notebook. Oh, yeah, we already talked about that. Khan Academy kickoff. We got a new video, but the thing that I need to tell you guys is, and I forget if I told you guys or not, I probably did on Tuesday, is I decided that it's not fair to have Math 8 competing with Math 7 because we do more work. Like, just honestly, your work is harder and therefore takes longer. So I'm not trying to say, like, we're better than them, but we're doing more difficult math. It should take you longer. So instead of us competing against the other periods, we're going to do Math 8 as blue versus green. So our con kickoff tomorrow, when we pull the data and check for this past week, will be blue versus green for you guys. That's it. Now I've thought about, I don't really have enough time to do this right now, but there's another strategy where you can also have the teacher compete against the teams. So I was going to make it blue versus green versus me. And, like, my average would just be me. But, like, I would be a team. But I don't know that I have enough time to do that right now. But here's another encouragement video for you.
What's up, Khan Academy students? Danny Green here.
Anyone know who Danny Green is? NBA player. He's fairly famous.
I just want to say Happy New Year. 2020 was a tough one. I know it was. But stay positive. Stay encouraged. Keep pushing each other. 2020 will be so much better. We have great things to come. So much more success. Keep putting your best foot forward. Bring the effort. Building new skills in the new year. Even in the face of adversity. But yeah, looking forward to a great year for you guys. Happy New Year. Stay safe. And I'm waiting to see what you guys come up with, the new skills and what you guys build. Take it easy and take care.
The biggest, most important thing I think he said, bring the effort. It is time, and normally we would get here much quicker in the school year, but because of COVID, y'all know what happened. It's time to bring the effort. And as other teachers have said, and I have said before, the honeymoon is over at this point. Normally we'd be there by October, when you're like, oh yeah, Phoenix is sweet, but dang, it's hard. Our expectations of you. So moving forward, here is how you will get a check in your math notebook. Check. If you do not have one of these, wait for a second to write stuff down. If you don't have one of these from in your math notebook, raise your hand and I will bring you one right now. It probably means that you did not turn in your math notebook to me yet. Probably means that you did not turn in your notebook yet. Good. You need another one? Whatever, you're good. I got a ton extra. Down there. So, on that same vein of bring the effort, some of us, and guys, I'm like, we're in that point, especially now that we're just very honest with you. Some of us, and by us I mean my students, not just people in this room, some of us are wasting our time. We're writing down a vocab word and not writing down what it means. We're writing down the beginning of a math problem when we're not solving it. Like, we're coming to class and doing the bare minimum, and you might as well not come to class. So, we're going to talk about what it's going to take to get a check on the next check, which is February 11th. So, if you want to make a note, you don't have to keep this in your notes, but if you want to, you could glue it in or tape it in or staple it in later. If you want to write these down, I would advise it wouldn't be a bad idea. If you choose not to write these down, I will tell you, like, if you get a check minus, I'm going to tell you, like, well, if you'd written down the expectations, maybe you would have remembered what they were. So to get a check in box number 1, what would I be looking for? What will I be looking for? Every class period, so maybe not every single day, right, because you don't have class every day, but every class period has a header with a date. So today, when we start our math notes, we will have a header, and we will have a date. These are not our actual, like, math notes. Now, for any of you who, like, when we go down this list, you're like, oh yeah, I was totally not doing that. I kind of want to hide all my notes that I've taken so far. I never again want to see any notes that you've taken prior to today. I'll say that again. I never again want to see any notes that you've taken prior to today, because some of you, they're real bad. By you, I mean all my students, right? So don't feel beat up right now. But some of you, your notes are real bad, and this is your opportunity to reset and do it better. Number 2, Nick, you should be writing these expectations down. Number 2, vocab is obvious and defined. You don't just write down the word scientific notation and underline it. You write down what it is. You write down why we use it. You write down an example of it. Number 3, essentially what I already talked about, if we write down a problem, it has a solution, right? Unless it was like the last thing in class and we didn't have time to solve it, if we write down a problem, we should write down the solution. And not just the answer, the solution, right? How do we do that? Not just the answer. And number 4, what do I mean by not a train wreck? Like, if you turn in a notebook to me that also has connections notes, and also has science notes, and also has social studies notes, and some pages face up, and some pages face down, and my handwriting is sideways, and that notebook's not even a graph paper notebook, it's a line paper notebook, that would probably be defined as a train wreck. So the other way that we could say, like, general organization and not a train wreck is 7th grade quality. Do 7th graders know that we start writing at the top of a piece of paper? Yes. Do 7th graders know that we write from left to right? Yes. Do 7th graders know how to make their handwriting legible? Yes. So all of these things really boil down to, are you bringing the effort? If you're only going to show up to class and exert like 10% effort, quite frankly, just don't show up. Like, love you guys, but you're on the advanced track. You could just take Math 8 again next year. If you don't want to do this, don't. I'm not making you. But I think we're all here because we want to be here. So I don't think this is as big of an issue for us. Any questions on... Now, I had the question earlier of, do we have to have all checks across here to get a check here? No. But I'm going to tell you, like, hey, next time, like, if this time your vocab was really weak and your definitions don't really like serve the purpose to define things, or if I notice that on masteries you can't remember the definitions for vocab, like I might tell you like, hey, this is a growth target. This is something we need to work on. But you could still get a check on the whole thing. Maybe you got headers, but you don't have dates, right? So last class somebody said, why do we put dates on our paper? First case, in case something happens and we need to put things back in order where they go. But the main reason is just to know when you did something. Guys, like anything you do is worth putting a date on to know when you did it. I built a workbench in my basement with my niece, and I had her write the date on it. So I can think back to like, oh yeah, that was in 2012. That was fun. Put dates on your work. Put your name on your work. Take pride in what you do. Any other questions? We today get to, oh yeah, the other thing. Sorry, that was very anticlimactic. If you miss any notes or need to check what we did, it's in here. Math 7 is first. Math 8, you have this orange post-it. You flip back to there. That's where my notes for the current section start. Bless you. My notes for everything up until winter break for you guys. That's not too bad. That's not very thick, actually. That was our notes for fall quarter for you guys. That doesn't feel like all of them, but I think it is. My Math 7 notes, about twice as thick. Yeah. So guys, I keep them all in a notebook, and that's why I was able to just pull them all out of the notebook, is they were in order. They were organized. Last call for questions. All right, this is where we left off the last time we had class. I'm not really planning on solving one of these, I'm not really planning on solving this one, because I think we at least started to solve it. But who can remind us with what we do here to solve with substitution? So now we're going to start our math notes, right? I'm not saying we have to write this down because we already did this last time. But so now either flip to a new page or draw like a pretty heavy squiggly line. Guys, what did we do here? Who can explain to me what we did to solve by substitution? Yeah, I'll try.
You substitute, so the equation x of x equals 2y minus 15. You put 2y minus 15 into the variable x, so it becomes ugly. So then if you load up the whole equation, it would be negative 5, and then in parentheses it would put...
Yeah, and we'd have to multiply out, right? So, as Akshay is reminding us, we put the whole expression for x in for x. So let's do one last review of this and do this top problem right here. Kelly, you got a question? So, exactly what I'm about to show. Your header could be solving systems graphically / algebraically. That is what we're doing today. We're solving systems graphically, algebraically. This is a tiny bit of review. Today is the 28th. Today is the 28th. So we start with these two equations. Since one equation tells us what x is, we take what we're told x is and plug it in for x. Coming over here to do that work, we have the negative 4y now plugged in. We can multiply. What do we get when we put a negative 8y with a positive 7y? A negative y. But if negative y is 3, what's that actually mean? If negative y is 3, what's that actually mean? Yeah, if negative y is positive 3, do the opposite on both sides. The opposite of y equals the opposite, the opposite of negative y, which is y, equals the opposite of positive 3, which is negative 3. Finish this out to find your x. What'd you get for x? 12. Guys, remember, you can shout stuff out. We're in class. We're together. We're collaborating. So, we then, in con, get asked to solve things graphically. And I bet I accidentally closed that link. I did. Well, that's embarrassing. Oh my gosh. Come on, Con. Alright, I'm going to go a bit more efficiently today, because I feel like yesterday when I was trying to explain what I was trying to get across, I felt like I failed a little bit. So, when we are asked to solve a system graphically, and when con gives us this whole use the utility to help you out, it's not necessarily nice and peachy keen because it's not in y equals form. Right? So we have there's probably more than two options. I say that a lot. Like I go to say we have two options and then there's really more. One option would be just choose whatever x you want that would fit on the graph, right? Choose whatever x you want and figure out what y would need to make this true. So, like, for example, if I look at these two functions and I say, okay, if I manipulate this around to get the x by itself, I can just subtract 2y from both sides. So, well, now I could choose the y if I wanted to. And if I have the 2x, 4y, negative 8, I could manipulate that around and move some stuff. I could try to isolate the y. Guys, we've got a bunch of options here. One of the easiest ways is just get it back to graphing form. Do you have a question, comment, or you just... What do you mean? Yeah, so you can actually, I think what you're trying to describe, a slightly better method of that, it's not really, I don't like calling it guess and check, but we can plug in a number and make it true. So not really like guess and check, but like determine, like substitute and determine, right? Like if I sub in a value for x, like guys, what I was trying to explain yesterday, and I will probably fail as much as I did yesterday, is if I plug in a y of 0, if I isolate the x instead of isolating the y, I can plug in a y of 0 and figure out x would have to be 2. Because if y is 0, x comes out to be 2. So there's a point that I have. And if I plug in a y of 1, or if I make x 0, I'm going to get this other value from just analyzing this algebraically. That would give me 2 points to then go to the graph and put those points on. Right, so I could put my 1 point at 2, 0, and my other point at 0, 1. No, 2, 0, 0, 1. Ah! Come on. Come on. Yeah? Okay. Then, if on the second function, no, just raising your hand to make fun of me right now. On the second function, if I force it into y equals form, because this is the other option we can take, we just start at the y-intercept, right? They tell us a y-intercept of -2, like from the graphing form. They tell us. We told ourselves. And then the slope is -1/2, so go down by 1, go over by 2. Boom. Wait. What does this look like? Kelly? Okay.
And B, you could have algebraically done this and found out if you simplify the second solution, you could have found that x plus 2y equals -4, and x plus 2y equals 2. So there's a difference of 6, and that means they'll never collide.
So, I love that you just said that. The other way we can analyze these things is, can this mathematically be, like, real? So, x plus 2y, I'm going to repeat what Kelly said because he said it fast. X plus 2y is equal to 2. They tell us that. If we divide this whole thing by 2, we get x plus 2y. But now it's equal to -8? Can this happen at the same time as this happening? Or, sorry, -4. Yes, thank you. Can this happen at the same time as... No. Not like they can't exist in the same place at the same time. They cannot both be true at the same time. They can both be true independently, but they can't both be true at the same time. Now the ways that make more sense than just like try to force it into a graph and like see if it works. Let's talk about algebraically how we know for sure if we have one or none or many solutions. So, a lot of times when we talk algebraically, we are talking about the equal values method. But I want to make sure that this all makes sense to us. So, take a moment, write down those first two equations. Tell me what your gut says, like what you notice. I forget how to get to my saved graphs. You didn't keep any of my... What? Come on, 22 hours ago I was using you and I had a ton of functions in here. What do you notice about -2x minus 4 and 3x plus 3 if I ask you about the slopes and the y-intercepts? They're different and different, right? So different slope, different y-intercept. So if we then go graph them... Wow, my camera's in a weird spot. We see one solution. And a lot of us have learned to love Desmos. Right? We don't have to go put these things in Desmos, and I don't want you putting these things in Desmos. I'm not saying you can't, and I'm not saying that's bad, but that's too much effort. After class today, you will know what to look for and immediately how many solutions there will be. So let's go ahead and make sure that we've written down for slope different and y-intercept different, we got one solution. Now, this next one. Go ahead and write down that next one. 9x minus 5, 9x plus 6. Oh, yeah, I will put it to the side. Yeah.
Another way that you could figure it out without just like looking at it, you could have proven it by what I did is since y equals negative 2x minus 4, and y also equals
Did you set them equal?
plus 3.
Yeah, did you set them equal?
Huh?
Did you set them equal or what?
No, so since they're the exact same thing, or since the two equations equal the same number, then you should be able to put them, or you will be able to put them as negative 2x minus 4 equals positive 3x plus 3.
Yeah, absolutely. So that is equal values method.
To get negative 7 equals 5x, and that ends up boiling down to the x intercept.
Yeah, so remember, in this case, though, we're just asking how many solutions. So you did extra work, which is fine. I'm always down with extra work. But right now, we're just trying to figure out how can we quickly determine how many. Later, we'll practice what is the solution. Right? So if we look at these two lines, what do you think about slope and y-intercept for 9x minus 5 and 9x plus 6? Same slope, different y. So what do you think that's going to mean? Yeah, they're parallel, right? So same slope gives us parallel lines. So when the slope is the same, is that a guaranteed no solution? Why'd you say no, Nick? Callie?
If the two slopes have the same y-intercept coordinate, that means they will run parallel to each other directly on top, meaning there are infinitely many solutions.
Can you think of an example like that in the real world? When something is just on top of each other, like something forever?
Y equals 2x plus 4.
No, that's mathematically. I'm talking in the world. So guys, check this. If I look at y equals negative 5x plus 1 and y equals 1 minus 5x, well, minus 5x, a positive 1, a positive 1. These lines are actually the same thing. And now, because they're purple and black, of course, this is going to be hard to see. But if I turn this line off or turn this line on, it just shows up on top of the other one. Same with this. Now, I know it's kind of hard to see because purple and black are pretty much the same color from as far away as you are. But think about when we pave a new road on top of an old road. It's not like when they start paving, they're like, man, we're going to turn the new road like a degree this way, and we're going to get creative. No, you follow the old road. You go parallel with the old road and right on top of it. Versus if you were to make a new road beside the old road to expand it, like y'all don't remember this, but hard road used to only be 2 lanes wide, and now it's like 5, right? It's like 2 lanes both directions and a center lane. So they built a new road beside that. It's never on top of the old road. They put a new road on top of the old road, but there's also a new road beside it. It will never touch, right? Yeah. Unless you have a better idea. I'm just giving you a hard time.
Most likely, you want to take the exact same line. There's never going to be a better line. There's going to be the fastest line, and everybody's going to want to try to get on that fastest line if they're just racing by themselves. So, like, if you're doing time trials, everybody's going to follow that line. Everybody's going to be like, yeah, I'm just going to drift over to the left, take this turn nice and slow.
And then crash into a wall.
Yeah, exactly.
So what I would like your notes to look like is this. To show an example of where we have slope different, y-intercept different, gives us one solution. If the slope is the same and the y-intercept is different, so same and different, we have no solutions. And if they are both the same, which this one's a bit tricky to see, right? They set it up a little bit different. I don't know how into Formula One you are, but my friend was telling me the other day about some like young guy who got hired onto the race team of this other guy who like isn't getting a card this year, like he's not racing that car, and the new guy beat his record in that car like first lap out, and they were like, bro, you kept talking about how the issue is the car, and this guy got in your car and he beat your best time. So, I forget who it was.
About a year ago, Red Bull driver, actually.
Maybe, yeah.
Came in, kicked the old guy off, beat his record. That guy went to a different team and ended up beating the same kid in the next race.
Well, that's how you do it, right?
Yeah.
Young buck comes up, challenges you.
Random Bolt.
Now, we got stuck here yesterday. So, I want you guys to take a moment with this, and I'll put my notes back up in case you were still writing it. But Kevin is 3 years older than Daniel. Okay. But 2 years ago, Kevin was 4 times as old as Daniel. And I don't want to hear anything from anyone until we write things down. I don't want to hear anything from anyone until we write things down. How can we talk about Kevin and Daniel? Who what? Sorry, speak up. Yeah, give them variables. So like K and D. Although my K's are kind of sloppy, we could probably say K and D. So how could we say Kevin is 3 years older than Daniel? Oh, that's what is means. Equals. So can I then just, if Kevin was 4 times as old as Daniel, can I just write K equals 4D? Why? They tell us Kevin was 4 times as old as Daniel.
Oh, because it said 3, 2, it said years ago.
Oh, crap. Wait, so 2 years. How do I deal with 2 years ago? Subtract 2 from what? From what? What do you mean by the whole equation? The whole. Adam's got to get it. We got to subtract it from both of the variables. So Kevin 2 years ago is Kevin minus 2. Daniel 2 years ago is Daniel minus. Okay. However, this is what they told me yesterday. I'm not sure if I agree with it. And they said, well, if we go up here, that works, right? Plug in a 4, plug in a 1. But
You could also do 2 if the D and then that would be.
You can do 0.5 for D and 2 for K.
But if D is 1, what's D minus 2? Negative. You're a negative years old. Not you're never born. You haven't been born yet. Because actually being a negative age old. Sorry, I'm trying to find our schedule to figure out how long I actually have. Where are you, schedule? I cannot find you. It might be here. So wait, what is another way? 38. Oh, I still have time. So wait, if we don't like what we just wrote, because the D that I got here makes Daniel a negative age, and well, that's not possible. Is there any other way that we could write this? I'm not saying our answers are wrong per se. What I'm saying is the answers we got don't make sense. Right? Like, Daniel can't be a negative age. So is there any other way we could write this? What if we think about the 2 years ago being now? So instead of talking about 2 years ago, the other situation we could talk about is if we go back in time, right? We hop in the DeLorean, travel back in time. Now we're at 2 years ago. The other equation that we have will be 2 years in the future. So if we want to change how we write this to try to make a tad bit more sense out of it, what if we start with Kevin is 4 times Daniel's age? Start in the past. And then project into the future Kevin in 2 years, Daniel in 2 years. Now, you get k plus 2, d plus 5. That comes out to be k equals d plus 3. And, well, quite frankly, that's what we had. But if we now say this is going to be true, okay, Kevin is 4 and Daniel is 1. What's k plus 2? What's d plus 2? Can Kevin be 6 and Daniel be 3? Yeah. Now, both of these situations are possible. Now, notice we didn't get a different answer. Because that's the solution, right? That's the solution to that system. And quite frankly, we didn't change the system. We just changed how we wrote it. So why I wanted to tackle this problem together is to talk about, all because you get an answer that you're like, well, no, that can't work. People can't be a negative age. Like, do not immediately tell yourself, I'm wrong. And I don't mean me, I mean, like, don't tell yourself that you are wrong. You can tell me that I'm wrong. I don't care. That's fine. But don't tell yourself that you have done something wrong. Ask yourself, like, well, wait, how else could this be looked at? We can't travel back in the future, but we can look into thank you, movies. We can't travel back to the future. That was number 1. However, we can, like, look into the future, right? Daniel cannot revert back to a -1, like sparkle in his parents' eyes, but he could grow by 2 years, right? Huh? Oracle? No, I am not the Oracle. So, those situations, those systems of equations with age are pretty fun, but they can make us a little bit timid when it's like, well, wait, that doesn't make sense because Daniel 2 years ago wouldn't exist. And you're right. So just flip how we look at the problem. Don't think about Daniel 2 years ago. Think about Daniel 2 years from now.
I hate your shirt very much.
Thank you guys. Oh, and the other thing, I forget if it was you who said it or if it was Adam Miller or somebody was complaining that they had already ingested all of my posters. They said there's nothing else to space out in here. You've got a lot of posters, but I've looked at all of them. So I have brought to us from my home, and if this disappears, I will be very sad, but I think I will be able to keep track of it. The Mensa Quiz a Day Genius Calendar. Wow. So, I will drop this into our slides, and if you would like to go try it, have at it. It should be the first thing when you go look at slides in Schoology. It is there. So if you finish your map test and you're all caught up on homework, there's a brain teaser for you. Some of these problems are easier. Some of them are literally genius level problem solving. Mensa is like a national, I think it might be an international club of like literal geniuses. Like very, very highly intelligent people. So this is the Mensa book for whatever year this was. It just gives you a puzzle every day. Little brain teaser. So I love Mark Rober. Probably, even if he decided to join. It's one of those like you have to like decide that you want to join, then you have to be allowed to join, and then I think you have to like pass a test.
I think he's smart enough to join.
Oh yeah, Mark Rober put stuff on like Mars. If you test here, yeah. Well, you probably know better.